Hello everyone. In this lecture, we are going to discuss about direct conversion of regular expression to DFA. There are four steps. First step is construct syntax tree for the regular expression. Okay, so here we need to consider the given regular expression is R means we need to construct a syntax tree for R followed by hash. Then compute nullable first position and last position. Then we need to compute follow position. From the follow position, we need to construct DFA. Okay, so here we are not going to construct regular expression into epsilon NFA and then into DFA. Okay, therefore it is called as direct conversion. We are going to directly convert regular expression to DFA. So first step is we need to construct syntax tree. So in a syntax tree, interior nodes represent operators and leaves represent operands or epsilon. Okay, terminal symbols or epsilon. Then we need to compute nullable first position and for last position. So this is the steps. Okay, these are the steps for finding nullable first and last. So here we need to consider there are 5 cases. Okay, the first 2 are the basis conditions, and the third next 3 are the induction steps or recursive steps. Okay, so the first one is if the node is a leaf node. Okay, if it is a leaf labeled epsilon means nullable of that node is true. Okay, nullable of node means if a language generated epsilon. Okay, if the subtree or if the particular node generates epsilon in its language, then we can say that nullable of n is true. Since leaf is labeled by epsilon, nullable of n is true. Okay, then if a leaf is labeled by any other position means except epsilon. Okay, any other position means it is false. It means if a leaf is labeled by any terminal symbol means then it won't generate epsilon. So nullable of that particular node is false. Then consider induction steps. So here we need to consider OR node, cat node, and star node. Okay, OR node means union operator. So if a node is n, node n is R node with left child C1 and right child C2. Okay, so if a node is a R node means then nullable of that particular node n is nullable of C1 or nullable of C2. It means any one of the child is nullable means we can say that this node is also nullable. Okay. Then for cat node means concatenated node. Okay. So if n is a cat node with left child C1 and right child C2, then nullable of n is true when both nullable of C1 and nullable of C2 are true. Nullable of C1 and nullable of C2 both are true means we can say that nullable of n is true. Okay, then star node. Okay, if n is a star node with single child C1 means then star node will always generate epsilon, right? It is 0 or more instances of the particular instance. So it includes epsilon. So the nullable is true. Then we can find first position by following these steps. So a leaf is labeled epsilon means there is no first position. First position of n is 5. Okay, first position means the first symbols generated by the particular node. Okay, it must be a terminal symbols. Okay, so here first position of leaf labeled epsilon is 5 only. A leaf labeled with some other position, okay, means some other symbols means then first position of n is that particular position I. Okay, here we will give integer numbers 1, 2, 3 for the leaf nodes. So that node, that position will be directly substituted here. Then first position of n, when n is a R node or union operator, then first position of n is first position of C1 union first position of C2. Okay, then first position of n for the cat node. If you want to find first position for cat node, first we have to check whether C1 is nullable or not. Okay, if nullable of C1, if nullable of C1, if this condition is true, Then this first position of n is first position of C1 union first position of C2. Okay, first position of C1 union C2. Else, suppose the nullable of C1 is false, means C1 is not null, means then first position of this node is first position of C1 alone. Okay, then for star node, first position of n will be first position of C1 alone. Okay, then last position. So for finding last position, it is similar to first position, but C1 and C2 are interchanged. Okay, so here a leaf is labeled with epsilon, means then last position of n is 5, similar to the first position. Then a leaf is labeled with position I, means last position of n is I itself. Then if a node is a R node with left child C1 and right child C2, then last position of n is last position of C1 union last position of C2. If n is a cat node with C1 and C2, two children C1 and C2, we have to check nullable of C2 here. Okay, here nullable of C1, here if nullable of C2 is true. If this condition is true, last position of C1 union last position of C2. Okay, last position of n will be last position of C1 union last position of C2. Else, it means whether, if nullable of C2 is false, means then last position of n will be last position of C2 only. Okay, then for star node, last position of this node n is last position of C1. Okay, next we need to find follow position. So first we will consider one example. After constructing the first two steps, after computing the first two steps, we will discuss about third and fourth. Okay. Consider this example. We need to construct a DFA directly from a regular expression A bar B star followed by BBA. So first step is we need to construct a syntax tree for A bar B star BBA followed by hash. Okay, the entire expression followed by hash. So first we need to construct a syntax tree. To construct syntax tree, we know that the interior nodes represent operators and the leaves represent operands or the terminal symbols. Okay, so here first we have to expand the parenthesis expression. This parenthesis expression has another parenthesis, inner parenthesis. So first we have to construct a syntax tree for A bar B. Okay, so for A bar B, vertical bar is a interior node, then left child is A, right child is B. Okay, A bar B. Then parenthesis. Okay, parenthesis is not a operator. So this is for grouping. Okay, only for grouping. So we have constructed A bar B. Okay, parenthesis A bar B we have constructed. Next, higher precedence is given for star. Okay, so next we need to do, we have to construct star syntax tree for star. So the interior node is star and its only child is the sub expression. Then this entire expression is concatenated with B. Concatenation is the next operator. For that concatenation, left child is the subtree, right child is B. Okay. So concatenation, for this concatenation node, cat node, left child is this subtree, right child is B. Then again this entire expression is concatenated with B. So this is the left child or subtree, left subtree for this concatenated concatenation node, and B is the right child. Then this entire subtree is concatenated with A. Then finally this entire expression is concatenated with hash. Okay, so for this node, this cat node, this is left subtree and right child is hash. Okay, after constructing this syntax tree, we need to give numbers for the leads. Okay, these are the positions. Okay, so here 1 2 3 4 5 6. We need to number the nodes from left to right. Okay, so the first step is over now. Second step is we need to compute nullable first position and last position. So to find nullable first position and last position, we have to redraw the same diagram. Okay, then we need to find first position and last position here. Okay, so in this step, we are going to mark all the first position and last position alone. Nullable will be used for whenever we are finding first position of cat node and last position of cat node. Okay, so we are going to record actually first position and last position for all the nodes. First position will be marked in the left side of the symbol, and last position will be marked in the right side. Okay, so first position of leaf. Okay, we have to start with the leaves only. So first position of a leaf labeled with a position. Okay, here leaf A is labeled with the position 1, means first position of that kind of node is I only. Okay, so that corresponding number itself. So 1. First position of 1 is 1. Similarly for B, 2. So first position of 2 is 2. First position of B is 2. Similarly, first position of this B is 3. First position of this 3, this B is 4. Here 5. And here 6. Okay, then we need to mark, we have to consider all the interior nodes. Okay, so now this is the R node. Okay, so to find first position for R node, first position of N will be first position of C1 union C2, right? So first position of C1 for this node is this one, A, and first position of C2 will be 2. So we have to perform union of these two. So this is 1 comma 2. Then first position of the star node. First position of star node is first position of the star node is first position of its child. Okay, so star node, its child is child's first position is 1 comma 2. So here we need to write 1 comma 2. Then first position of cat node. Okay, so to find first position of the cat node, we have to check this. Okay, so if nullable of C1 is true means then first position of C1 union first position of C2. So first we have to check whether nullable of C1 is true. Okay, for this cat node, C1 is star node. For star node, nullable condition is true. Okay, this is the nullable column. So nullable for star node is true. So true means nullable of, first position of this node is first position of C1 union C2. So it is 1, 2, 3. Then first position for this cat node. So again, this is also similar to this node. Okay. So nullable of C1, if we want to find first position of this node, we need to check whether nullable of C1 is true. Okay, since C1 is a cat node, how to find nullable? Cat node means both C1 and C2 must be nullable. Okay, nullable of C1 and nullable of C2 both must be true. Then only we can say that nullable of the node is true. Okay, so we need to find first position for this node. So we need to check whether nullable of C1 is true. Okay, so nullable of C1 is true means it's a cat node. So both its children must be true. Star node is nullable. Okay, so nullable of star node is true. So C1 is true, but what about C2? If a node is labeled with some other position means nullable is false. Okay, so C1 is nullable, but C2 is not nullable. So as per and condition, both must be true. So here both are not true. Okay, one is C1 is true, but C2 is not true. So nullable of C1 is false. Nullable of C1 is false means what is first position of the node N? First position of C1 alone. Okay, so C1 is this one. So we have to write 1, 2, 3. Then for this node, okay, so to find nullable of this node, again we need to check uh, nullable of C1 is true. Okay, if this must be true means both C1 and C2 must be true. We know that nullable for a node labeled with some other position is false. Okay, since C2 is false, no need to find C1. We can say that nullable of the cat node is false. Okay, so since this is false, we have to copy only first position of C1 alone. So 1, 2, 3. Okay. Then similarly for finding first position for this node, we need to check whether nullable of C1 is true. Okay. So since it is a cat node, if it should be true means both C1 and C2 should be true, but we know that C2 is false. So we can say that this is not null. If it is not null, we need to substitute first position of C1 alone. Okay, 1, 2, 3. Now we have to mark all the last position for the symbols. Okay, so last position for a node labeled with some position means the same I. Okay, position I means same I. So here 1. So last position for this leaf is 1, this leaf is 2, this leaf is 3, here 4, here 5, and here 6. Now we need to consider the interior nodes. Okay, so last position of R node is similar to first position. Okay, last position of R node means last position of C1 union C2. So this is last position of C1 and C2. So union of these two will be 1, 2. Then for star node, so for star node, what is last position? It's children. Okay, it's child. So last position of star node is last position of its child. So 1, 2. Then last position of this cat node. If you want to find last position for cat node, uh, we need to check whether nullable of C2 is true. Okay, if nullable of C2 is true means we need to apply this, else we need to apply this. Okay, nullable of last position of C2 alone. Okay, so we have to check whether nullable of C2 is true. For this cat node, this is C2. Okay, we know that a leaf labeled with position I is not null. Okay, it is false. So since it is false, else part is applied. Last position of C2. Okay, see, last position of N will be last position of C2. So this is last position of N is equal to last position of C2. It means we need to substitute 3 here. Similarly, this is also a cat node. So we need to check if nullable of C1 is, C2. Nullable of C2 is true or false. Since this is not null, we can just copy last position of C2 alone here, 4. Similarly, for this cat node, last position, nullable of this node is false. So we have to copy only 5. Otherwise, we will copy union of these two. Okay. And for this cat node, this is the node C2. So this is not null. So we have to copy only 6. Okay. Next, we need to find follow position for all the nodes. Okay. So this is the procedure for finding follow position. So to find follow position, we need to consider only cat node and star node. Okay. So if n is a cat node with left child C1 and right child C2, like this. Okay. N is a cat node with left child C1 and right child C2. Then follow position of last position of C1 is equal to first position of C2. Okay. So this is C1. Here we will mark first position of C1 and this is last position of C1. This is first position of C2 and last position of C2. So to find follow position of last position of C1 is equal to first position of C2. So first position of C2 must be applied to um, last position of C1. Okay. Follow position of last position of C1. Similarly, if N is a star node, then N is, this is N. Okay, this node is N. Similarly, This node is n here. Okay. So n is a star node with single child. Okay, we are not going to worry about the child here. So if n is a star node and it has first position and last position, no. So to find follow position of last position of n is equal to first position of n. It means first position of n must be applied to follow position of last position of n. Okay, so in this example also, we need to find follow position for all the nodes. Okay, all the positions. Here we have 1 to 6, no? So we need to find follow position for 1 to 6. Okay. So here we have 6 nodes. So we need to write all the 6 nodes here. 1, 2, 3, 4, 5 and 6. Then we need to find follow position. So to find follow position, we need to consider only the star node and cat node. Okay. So from the leaves, we need to check this is the first star node. So to find star node, what is the rule? Uh, Follow position of last position of n will be first position of n. Okay. So what is first position of this node? 1, comma 2. That must be substituted to 1 and 2. Follow position of 1 and follow position of 2. Okay. So follow position of last position of n. Last position of n means 1, comma 2. So follow position of 1 and in follow position of 2, we are going to substitute 1 and 2. Okay. So in both follow position of 1 and follow position of 2, we need to write 1, comma 2. Then we need to consider cat node. Okay. So for this cat node, we need to consider C1 and C2. Okay. And what is the rule? First position of C2 must be substituted to follow position of last position of C1. Okay. See this? First position of C2 must be substituted to here. Okay. So 3 must be substituted to follow position of 1 and 2. So 3 must be substituted to 1 as well as 2. Then in this cat node, here this is C1 and C2. So 4 should be substituted to 3. Okay, 4. Then for this cat node, this is C1 and C2. So first position of C1 must be substituted to last position of follow position of this 4. Okay, so 4. In 4, we need to substitute 5. Then for this cat node, 6 must be substituted to 5. Okay, that's all. So we can close all these sets now. And this one is nothing. Okay. Now we need to construct DFA for our given problem. Okay. To construct DFA, start state must be first position of the root. Okay. So what is first position of root? 1, 2, 3. So 1, 2, 3 will be our start state. 1, 2, 3 is our start state. Okay, start. Then so to find DFA, we know that the start state will be the first position of the root. First position of root is 1, 2, 3. So 1, 2, 3 we have to mark. Okay, then to find transitions from all the states, here we need to consider the input symbols A and B. Okay, here the state is 1, 2, 3. So now we need to check in 1, 2, 3 wherever A occurs. In 1 only. Okay, out of 1, 2, 3, A appears in 1. Now we need to find follow position for 1. Follow position for 1 is 1, 2, 3. So from 1, 2, 3, state 1, 2, 3, A goes to 1, 2, 3 itself. Okay. Then from 1, 2, 3, among 1, 2, 3, B appears in 2 and 3. Okay. So we have to find follow position for 2 and 3. So if you perform union of these two, we will get 1, 2, 3, 4. So it's a new node. So we have to construct that node now. Okay. So now from this node to this node, we have to draw an arc and that arc is labeled by B. Now from this node, we need to construct transition on A, 1, 2, 3, 4. Okay, out of 1, 1, 2, 3, 4, A appears in 1 only. Okay, so follow position of 1 is 1, 2, 3. So from 1, 2, 3, 4, A goes to 1, 2, 3. Then from 1, 2, 3, 4, in 1, 2, 3, 4, B appears in 2, 3 and 4. Okay, 2, 3, 4. So follow position of 2, 3, 4 means 1, 2, 3, 4, 5. It's a new node. So we have to construct that state now. 1, 2, 3, 4, 5. So now from this state, B goes to the newly created state. Okay, now from 1, 2, 3, 5, 1, 2, 3, 4, 5, among 1, 2, 3, 4, 5, A appears in 1 and 5. Now find follow position for 1 and 5. It is 1, 2, 3, 6. This is also a new node. So we have to construct that node now. 1, 2, 3, 6. So from this node, A goes to 1, 2, 3, 6. Then from 1, 2, 3, 4, 5, B appears in 2, 3, 4. So if you perform, if you find follow position for 2, 3, 4, we will get 1, 2, 3, 4, 5. Okay, so it's a self transition for B. Then from 1, 2, 3, 6, 1, 2, 3, 6, A appears in 1 alone. Now follow position of 1 is 1, 2, 3, 1, 2, 3. So from 1, 2, 3, 6, A goes to 1, 2, 3. Now from 1, 2, 3, 6, B appears in 2 and 3. Now the union of follow position of 2 and 3 is 1, 2, 3, 4. So from 1, 2, 3, 6, B goes to 1, 2, 3, 4. Okay, this is B. Now we need to mark all the final states. So to mark final state, make position associated with hash as the final state. Okay, here hash is associated with 6. So what are all the states containing 6 are the final states? Only this state has 6. So we need to mark this state with the double circle. Okay, so this is now a final state. So this is the resulting DFA for our given regular expression. And this is the direct method. Okay, thank you.